So you just watched a video that recapped what we learned way back when about Pythagorean identities, and it also derived the two additional ones that we're really going to be using a lot here in this last unit of our course. So I just want to start by jotting down those three Pythagorean identities that you saw. If you didn't get a chance to, you can print out this page, or if you have a touch screen, you can write right on it. But the Pythagorean identities, the more popular one is the one we've used a couple times now. That's sine squared plus cosine squared equals 1. And then our two derivations of that, the first one would be 1 plus cotangent squared equals cosecant squared. And then the second one is tangent squared x plus 1 equals secant squared x. So for today's lesson, we'll be using these three interchangeably depending on what's given to us in the problem. The other thing that I want you to recall from way back when are the reciprocal identities. So remember that there are 6 trig functions. If we just start with those, we've got sine x and cosecant x. We've got cosine x and secant x. And then we've got tangent of x and cotangent of x. And those 6, each pairing vertically, are reciprocal identities. So what that means is that for each one of these, we could write it as a fraction. So sine of x could really be 1 over cosecant x. We don't typically do that, but we can. Cosecant x, we can rewrite as 1 over sine x. And then we can do the same for each one of these. So cosine x would be 1 over secant x. Secant x would be 1 over cosine x. Tangent is 1 over cotangent. And cotangent is 1 over tangent of x. And what that also means is that while we don't often write 1 over cosecant or 1 over sine, how we're going to be using that is if, sine of x equals 2/3, then cosecant we could write as 3/2. We can just flip the fraction. So keep that in the back of your mind as we're working through our notes for today. All right. So example 1, showing us what we're going to be doing with these Pythagorean identities and then how the reciprocal identities are going to fall into place. So our given information here, we know that tangent of theta is -2/3, and theta is in the 4th quadrant. So right out the gate, I'm going to do a quick sketch. All students think critically. We know that we're in the 4th quadrant here, so 4th quadrant is over here. And if you recall, the all students think critically that I just said is reminding us of what trig functions are positive in each unit or in each quadrant. So the A for all means all, sine, cosine, everything is positive in quadrant 1. We're focused on quadrant 4, so that means that cosine is positive in quadrant 4. So when we, come back to this at the end and talk about sines, we need to recall that information. So theta is in the 4th quadrant, and our task is to find the values of the remaining 5 trig functions for theta using these Pythagorean and reciprocal identities. So when we're all said and done, I'll jot this off to the side as well. We need sine of theta, we need cosine of theta, tangent of theta, and then the reciprocal identities. So cosecant of theta, secant of theta, and cotangent of theta. And the good news is they already gave us tangent, so I know that's -2/3. So I can fill that one in straight out the gate. Now, what we're going to be doing for this, we're going to call this exact values. So we're not going to be using a calculator for this really at all, other than, perhaps in the equation solving that we have to do here. But basically, because they gave us tangent here, I'm going to look back up at the top of the note sheet and identify which Pythagorean identity uses the tangent function. And if you looked back up at the top, we should be using the one that is tangent squared of x, in our case theta, plus 1 equals secant squared of x. Okay, and x could be theta, it could be whatever the variable is for the angle. Technically, we're talking about theta here. And then we're just going to plug in what we know. So we know that tangent of x is negative 2/3. Well, if we have tangent squared of x, what that means is we're going to replace this first piece of the expression with negative 2/3, and then we're going to square it because it's tangent of x squared. And then if I continue writing, so plus 1 equals, and we don't know anything about secant squared of x yet. Now, from here, we're just going to solve for secant squared, and then eventually we will be able to solve completely for secant x all the way down. So that'll give us another piece of the 5 trig functions that are left over. So if we use our algebra rules, when you square something, you square both the top and the bottom. So negative 2/3. Note here, anything negative when you're squaring it is going to become positive. So after this step, we shouldn't see any negatives. So we would get 4 over 9. Negative 2 squared is 4. 3 squared is 9. Still plus 1. However, the 1 is manipulatable to whatever number we want it to be. Because I'm going to be adding fractions together, we're going to have to be adding common denominators. So I'm going to go right ahead and change 1 to 9 over 9. So now I have that common denominator of ninths for both of the values there. All right, so now I can combine the fractions together, just add across the top, keep that denominator the same. And then here, because I'm looking to solve and get secant of x, or secant of theta in this case, I need to get rid of the squared sign. So I'm going to take the square root of both sides. But when I do that, remember that when you take the square root on both sides, that means there could be a positive or a negative answer to this problem. So in this case, we were looking at plus or minus. Root 13 does not reduce at all, so we'll leave that alone, but the 9 will. That square root of 9 is just 3, and that gets us secant of x. Now, in this case, let's go back to the quadrants that we talked about at the very, very beginning over here. So because theta is in quadrant 4, that's where cosine is positive. Since secant and cosine are reciprocal identities, that would also imply that secant is positive. So what I'm going to be able to do is come back over to the plus minus sign, and I can actually get rid of the negative in this case because we know that we're in the 4th quadrant where secant is positive. So that means for secant over on our chart here, we're looking at positive root 13 over 3. Now, there's a couple ways to finish filling out the chart. In this case, one of the things that we can also recall is SOHCAHTOA. So because we have the negative 2, the 3, and the root 13, we really have all 3 sides of the right triangle that's really in play here. So what we could do is write O, A, and H, and identify from SOHCAHTOA what the opposite, the adjacent, and the hypotenuse are, and then we could just fill in the rest of the pieces of the puzzle. So tangent, if you recall, is the TOA, opposite over adjacent. So in this case, the opposite would be 2, the adjacent would be 3, which means kind of by default that it would make sense for root 13 to be the hypotenuse, which is correct because secant is hypotenuse over adjacent. Now notice that I didn't carry any negative signs in there because, again, each of the trig functions is going to have a positive or negative based off of the quadrant it's in. So I'm always going to leave those 3 values positive and then think about signs after I write in all the fractions. The other thing, going back to reciprocal identities, is because I have tangent, I can just flip that and I immediately get cotangent. So that would be negative 3/2. And cosine, because I have secant, I'm going to be able to flip that and get the cosine value. Now, careful here, we do want to rationalize. So when I flip secant, let's bring that out here. When I flip secant, that would be 3 over root 13. Remember from, again, way back when, that means we have to multiply by root 13 over root 13 to get that to rationalize. So the cosine value, when I multiply those together, would just be 3 root 13 all over 13. Now, sine and cosecant, because they had no kind of play here in the Pythagorean identity that we used, I'm going to go to this concept of opposite, adjacent, and hypotenuse that I figured out. Sine is opposite over hypotenuse. So sine is technically, I'm going to write it up here, 2 over root 13. And we run into the same issue. So I'm going to multiply by root 13 over root 13. And the same thing happens as did with cosine. We get 2 root 13 over 13. And cosecant, I mean, I could flip the fraction I just created, or I could just go back and say cosecant is the reciprocal of sine, which is hypotenuse over opposite in this case. So I would just get root 13 over 2. Last thing to consider is the negatives. Again, going back to this quadrant thing, cosine is positive in quadrant 4, as would be then secant. So everything else should be negative. So tangent and cotangent, I already have the negatives in place, but I do need to add it in here, just sine and cosecant, because they would also be negative in the 4th quadrant. So now we have our 6 trig functions. At this point, what I would like you to do is go ahead and pause the video. And I want you to try example 2. If you get stuck, feel free to play out the video as I'm going to work my way through them. But I want you to try it on your own and see what you can do with it before I go over it. Go ahead. All right, so for question 2, practice problem number 1, we're looking at cotangent of theta equals negative 1/3. This time they're giving us an inequality, which really is just them telling us what quadrant we're lying in. And again, we're tasked with finding the remaining trig values. So very similar question to the first one. So in this case, cotangent means that we want to look at the Pythagorean identity that is 1 plus cotangent squared. And we are using theta, so I'll use theta this time, which is equal to cosecant squared of theta. Now, this interval that they gave us using the inequalities, if we think about our quadrants, 0 obviously is over here, positive x-axis. Where would negative pi over 2 be as an angle? Well, remember, negative angles rotate clockwise, so downwards, and pi over 2 is typically at the 90 mark, the positive y-axis, so negative pi over 2 is going to be down here at the negative y-axis. So again, we're in quadrant 4. So all students think critically. Again, C, cosine, and secant are going to be our positive trig functions here. So if you wanted to, one thing that you could do is, let's write out what all we need to find: sine, cosine, and tangent. And then we'll need cosecant, secant, and cotangent, which they actually did give us, so we can fill that one in. It's negative 1/3. One thing that maybe you want to do so you don't forget this piece right here is you could just put the signs in right away. So if I know cosine and secant are positive, then I automatically know sine's going to be negative, cosecant's going to be negative, and then tangent, which automatically I get tangent by just reciprocal identities. I can make that a negative 3, or if you want to put negative 3 over 1 to show the true reciprocal, that's fine too. Now, back over to our Pythagorean identity. We got to plug in what we know. So they gave us cotangent, so I can rewrite this as 1 plus cotangent squared. So cotangent is negative 1/3, that quantity being squared. And then we would be solving for cosecant in this case. Again, I'm going to start with the second term. Actually, I'm going to square first so I can see what that fraction is going to be. So negative 1 squared would just be 1. 3 squared, again, we get a denominator here of 9. So that 1, I'm going to automatically transition to 9 over 9. So I have a common denominator. And then adding our two fractions together, we get 10/9. And last step is to get rid of that squared sign because we're solving for cosecant of theta. So we have to take the square root of both sides, but don't forget, automatically plus minus. We kind of already talked about this for this one, but again, that's why we're allowed to do the negative in this case for cosecant, because when you're taking the square root, it allows you to have either answer. So in this case, again, root 10 does not reduce, but 9 does reduce. It's not 9, it is now 3. And we're looking at just cosecant of theta. So now we know that cosecant is actually going to be negative root 10 over 3 in this case. Here again, I can automatically find sine by using reciprocal identities. I'll write that one off to the side because, again, we're going to end up having a radical in the denominator. So, again, we got to rationalize. So sine would really be 3 over root 10. But, again, we'll just multiply by denominator over denominator, root 10 over root 10. And we get, in this case, negative 3 root 10 over 10. Now, cosine and secant are the two that we don't get any information about based on what we have. So I'm going to find the opposite, the adjacent, and the hypotenuse from the information that we do already know. So they gave me cotangent out the gate. So cotangent is adjacent over opposite because it's reciprocal of tangent. So the adjacent would be 1, the opposite would be 3, which means by default that the hypotenuse here would be root 10. So cosine is adjacent over hypotenuse, which is 1 over root 10. Again, we got to rationalize. And that means we're looking at cosine to be positive root 10 over 10. And then secant is hypotenuse over adjacent, which is root 10 over 1, or just root 10, however you want to write it is fine. And again, that at this point finds all 6 trig functions. We found the remaining 5 that they were looking for. Again, I'm going to suggest at this point that you pause the video, and hopefully this second one was enough that you can work your entire way through example 2 and then just come back to the video to play out and check your answers. If not, I'm going to go through that one too. Good luck. All right, so for example 3, this time they're giving us cosine, and we know that theta is in quadrant 3. So again, if we draw out our all students, think critically, we're in quadrant 3. So tangent is positive here, which means that cotangent would be as well. So I might come down here and put my positive negatives in right away, just so I don't forget it. But again, make sure that you're referencing that at some point in your work. You don't want to lose points because you forgot a negative. Because if you forget it one place, you'll probably forget it everywhere. All right, so tangent and cotangent are positive, which means I need negatives in all of the other trig functions. All right, now this one actually, given cosine, we're using the original sine squared plus cosine squared equals 1. So you've actually done this problem a couple different ways at this point. I'm just going to show you how to do it the way that we've been doing all the other problems. So in this case, we know sine squared of theta plus cosine squared of theta always needs to equal 1. So we don't know sine squared of theta here. We do know that cosine of theta is negative root 3 over 5. And we're going to square that and set it equal to 1. So sine squared of theta plus, all right, in this case, negative root 3 squared. What happens here, the negative cancels, and the root and the squared sign cancel. So we get 3 over 5 squared is 25. And here again, even though we're not adding fractions this time, think about how to solve in the next step. I would have to move the fraction 3/25 to the other side. So I'm going to change 1 in this case to 25 over 25. All right, and then sine squared of theta will equal, we'll subtract over the 3, and we get 22 over 25. All right, so we're looking for sine squared, which means we got to take the square root to get rid of our squared sign. So sine of theta is going to equal positive or negative. Again, we already discussed that in this case, sine is going to be negative here, but I'll put it in there just to remind you. 22 does not reduce under the radical, so root 22 over square root of 25, we're back down to a 5. So sine of theta would be negative root 22 over 5, which then means, in this case, cosecant, I'm going to skip the rationalizing step. You would still do that, but you will just get negative 5 root 22 over 22. Okay, and we also can fill in what we knew from the get-go, which was negative root 3 over 5 for cosine. Again, I'm going to skip the rationalizing step. You should get negative 5 root 3 over 3 for secant. And again, that's just by using reciprocal identities, just flipping the fraction, and in this case, we had to rationalize for cosecant and secant. Now, for tangent and cotangent, again, I'm just going to identify what the opposite, adjacent, and hypotenuse would be for this case. So I'll look at the sine function. Sine is negative root 22 over 5. Sine is opposite, so the opposite would be root 22. And the hypotenuse then would be 5. The adjacent we can get from cosine. Cosine's adjacent over hypotenuse, so root 3 would be our adjacent. So now something interesting that happens here is when we write tangent, we get root 22 for the opposite over root 3 for the adjacent. So this one I will rationalize because it works out a little bit differently than the other ones. When we multiply by the denominator, top and bottom, remember that under the radical, you can multiply the numbers together. So we're going to get root 66 over 3. So tangent is going to be positive because we're in the third quadrant, root 66 over 3. Cotangent, then we will take the reciprocal of that. And this one is just a regular rationalizing. You end up getting root 66 over 22. All right, so at this point, those are the 3 practice problems that you have in your notes. There is an exact value worksheet attached to this lesson that you can try, and then tomorrow the key to it will post for you to check your own work. Good luck. Let us know if you have any questions.